we're going to move on to periods of the sine and the cosine function. Now, we talked about yesterday that the period is the length over which the wave completes one cycle. So for any wave, right? Let's say if you start here and if you complete one cycle, that's one period of it. Okay? Now you don't have to have that as your starting point. What if you have this as your starting point? Basically, you have to run through one cycle and get to the same point vertically. So right here, okay, we get to the same point vertically. That's one full cycle of the wave. On the x-axis, the length over which that happened is called the period. The default for sine and cosine, the default period for sine and cosine is 2 pi. But that's not always the case. So, for instance, you may have a wave that progresses like this. You may have another wave that's a little bit faster or much faster. All right? In real life, that's the difference, how fast the wave is. That's the difference between, let's say, a light wave, a microwave, an X-ray, a gamma ray, a radio wave. All right? Radio waves are very, very slow. X-rays are very, very fast. So that is the difference in the period. Okay? And it makes a difference in what type of wave we're looking at. All right? Yes?
Is the period like the time or just how long it works?
It's how long on the x-axis. And the x-axis could be different units. It could be time. It could be something else. All right. Given an equation, to find the period, it's 2 pi over b. Okay? So 2 pi over the absolute value of b. 2 pi over the absolute value of b. All right. So let's take a look at this first one here. You have sine of 2x. Now, remember that b is the number right in front of the x, right? So it's sine bx. So look at the first one here, sine of 2x. The one immediately to the left of x is your b. So for the period, it's going to be 2 pi over 2 pi. Okay? Right. The next one, it's going to be 2 pi over what number? 3. And that is already simplified. You can't simplify it anymore. I am going to ask you that when you have a fraction, you must always simplify it. So for example, the first one, you're not going to leave it as 2 pi over 2 because that's going to be confusing. You have to simplify and reduce anything that can be reduced. All right? Okay, now this next one, what's b? B is a half. So the period is going to be 2 pi over a half. Okay? Now, some people can do this in their head. Perfect. Some people need to write it down. Perfect. Makes no difference. Okay? If it's going to minimize the mistakes that you make and it's going to maximize the points that you get for the problem, write down the steps to do it. All right? So this is going to be 2 pi times, and I already see some people saying 2 over 1. Okay? How much pi? How many pi? 4 pi. So remember, this is over 1. 2 pi times 2 is 4 pi. All right? Question. So this is 2 pi over what number? 1/5. So that's going to be 2 pi times 5 over 1, 10 pi. Okay? Huh? The 3 doesn't make a difference. So the mental way, okay, like if you want to do mental math, it's 2 pi over 1 on top and 1/5 on the bottom. We multiply numerator to denominator. So if I see this, I multiply, numerator to denominator. If you don't see it immediately, take a second and write it down, all right? It'll be so much more helpful. All right, let's take a look at the other one. It's 0.25, right? So that's, what is it? 1/4. Awesome. So it's 2 pi over 1/4, and that's how many pi? 8 pi. Normally, we don't like to mix decimals and fractions. It's not good form. And we want to have good form.
It's also easier.
Yeah, it is easier if it's a fraction. So 2 pi over 3 pi, what is that? 2/3. And that's okay too. All right?
It doesn't have to have a pi.
No.
How is that?
Well, if it's pi over 2, how much is pi? 3.14. So it's really 1.57 units
But how
long.
do you do
Because
it
the
on
pies
that?
You just do it instead of the pi's. It would be 1 over 2 and 1 and so on. Just regular old numbers. That works too. Okay, so we're going to graph a couple right now. Okay? So it asks for the period, and I want the period of g of x. So that's going to be, what is it? 4 pi. All right, so the period is going to be 4 pi. Now, I want to know what the graphing region is, okay? So here is what we're going to do. Stick with me on this, and we're going to do it every single time. We're going to do it the same exact way, and you're always going to get it right, okay? So, what we do is this. You take the stuff here after the sign, so it's half x, all right? And we're going to make an inequality. Now, normally, the regular old default sign of x goes from 0 to 2 pi, right? So we're going to make this go from 0 to 2 pi. And now look, it's algebra 2 or intermediate all over again, all right? How did we solve this way back when?
You divide by multiply by 2.
We need to, okay, so what we need to do is we need to solve for x in the middle. If it's half times x, well, what I'm going to do, even simpler than that, I need to get rid of the 1 over 2 in the middle, so I multiply by 2 over 1, 2 over 1, 2 over 1. Okay? So now, that goes away. What's 2 times 0? 0. X, and this is going to be 4 pi. Oh my, look at that. So, how much distance is there from 0 to 4 pi? It's 4 pi. What did we say the period was? 4 pi. Okay, so those have to be consistent.
So that's another way of
That's another way of checking that you did it right. So if you did this right, those two have to be consistent. So my graphing region now is 0 to x to 4 pi. All right? What does that mean? When I do my when I do my x-axis, you remember how we were always going like from the first point and then 1, 2, 3, 4 to the last point? Same situation. First point, 1, 2, 3, 4, last point. And now I need to find midpoint, midpoint, midpoint. So here's how we do it. Stick with me. I'm going to color code this so we know what we're doing. The 4 pi. It's 0 to 4 pi. The very, very middle of this, okay, is 2 pi. You can see it for ones like this. Perfect. Sometimes you can't see it, and that's fine too. What we do is we take the point at the very beginning, we take the point at the very end, we add them, I get 4 pi, and then I divide by 2. and I get 2 pi. That's going to come in very, very handy when things get a little bit more tricky. Now, the first increment there, the first quarter point, that green one that I just put there, that's the point between the 0 and the 2 pi. How much is that? What, between 0 and 2 pi is pi. And now the next one, that's the point between 2 pi and 4 pi. So look at what it is, 3 pi. I add them if I can't see it immediately, and then I divide by 2. Okay? Anytime you want to find the middle of 2 points, you add, you divide by 2. You add, you divide by 2. You add, you divide by 2. If I want to find the midpoint between the red and the purple, I add, purple. I divide by 2. 6 pi divided by 2, 3. Make sense? It's math. It's got to make sense, right? So half of 6 pi is 3 pi. All right? Now, believe it or not, that was the hard part. The actual graphing of the sign, that's the easy part. Okay? So where are we going to start? Where's the first point going to go? 0. And then 1, and then
2 pi.
0, and then negative 1.
And then 0. I thought it was half.
Okay, so you see that?
Whoa.
Okay, what is the number to the left of the sign? 1. The number to the left of the sign is 1. Your amplitude is 1.
Oh, so the period just means the numbers we put on the graph.
Correct.
Oh my goodness.
Now,
The left of the side, what you're talking
to the left of the sign here, the coefficient, if there is nothing there, it means there is an imaginary 1 here. That means the amplitude is 1. So, let me, before I take questions, let me talk to you about what exactly is it that happened here. Yesterday, when we were graphing signs, it always started at 0 and ended at 2 pi, okay? So it started at 0 and ended at 2 pi. So that means it always looked like this. Bear with me here. Okay? So look, the default sign would be the one in the black. Starts at 0, ends at 2 pi. The fact that this one was sine of half x, it means now the wave has changed. It's been elongated. So it starts at 0 and it completes the cycle in twice the time. The black line is just sine of x, like we were doing yesterday. It starts at 0, ends at 2 pi. This time it started at 0, ended at 4 pi. This is a slower wave.
You have to draw the sine of x.
No, you don't have to. I just put it there to show you what happened, like what is the difference. So this would be the difference, let's say, between a higher frequency note, like in the black, and a lower frequency note. Okay? A higher frequency note would be like a D or an E, and this would be a C, for example. Okay? Those of you that are musically inclined. This is the difference between a gamma wave, a gamma ray, which is deadly. It's just a wave that goes very, very fast. And a radio wave, which you can listen to all day long and nothing happens to you.
What's the waves
all right?
when you're like in the hospital? What are those waves?
There is another way that waves are useful. Okay, let's do one more. To be 2 pi over 3, and it's simplified, and that's it. Okay? So it's going to complete a whole cycle from 2 pi to 3, from 0 to 2 pi over 3. All right. So now we have to figure out the graphing region. We take this number, that quantity, 3x. Now, we're graphing cosine. So you think to yourself, okay, the default cosine goes from 0 to 2 pi. The default cosine goes from 0 to 2 pi. So 0, 2 pi.
Is it always going to be from 2 pi to 3x less than or equal to?
Yeah, it's always going to look like this
Okay.
for sine and cosine.
Wait, so it's always gonna be 2 pi, right?
For sine and cosine, yes. It'll change for tangent and cotangent.
Wait, so we should
I'm scared.
times everything by 3? Yeah.
Huh?
You write 2 over 3.
Wait, so hang on, that's next. So now,
Everything by 3? Times over 3.
well, okay, so let's think. It's 3 times x. We want to do the inverse. The inverse of multiply is divide. So divide by 3, divide by 3, divide by 3.
Why do we multiply?
What I get is 0, x, and 2 pi over 3. So that's my graphing region, is from 0 to 2 pi over 3. Okay, now, so stay with me on this. I start at 0, 1, 2, 3, 4, and that's pi over 3. I'm writing it to the right of it just for spacing purposes. 2 pi over 3, sorry. Okay?
How do you know that?
Because that's what the
0.
ending
No,
point.
how do you know that's where it is on the graph? Oh, you always go 4 from 0.
You start here and then you go 1, 2, 3, 4.
Oh, you always do that.
Yeah. We need a total of 5 points. Okay, now I'm going to color code this again. Exactly in the middle, okay, we take the very beginning, the very end, we add and divide by 2. Stay with me. Let me do this first one. We take the very beginning, we take the very end, we add. Dividing by 2 is like multiplying by a half. So, go slow. Half times 0 plus anything is that anything. Now, reduce the 2's, so I have pi over 3.
Why do you divide by, I'm so sorry. Is that the same thing as 1/3 pi?
Right. So now, could we have done this mentally? Let's see. We're going from 0 to 2/3 pi. Halfway is 1/3 pi. Okay? If we can't do it mentally, we add and we divide by 2. Okay? Before I have had my coffee in the morning, I write stuff down and I add and divide by 2. After I've had my coffee, sometimes I can do it mentally. Okay? Yeah.
So, like, would it be like.
The first quarter point here, that's the point right in between 0 and pi over 3. You see the reasoning? What do I do to get the middle? I add and I divide by 2. So now, this is half of. Anything plus 0 is anything, right? It's that number, pi over 3. Now, there is nothing that I can cancel to reduce. I multiply the tops, I multiply the bottoms, and I get pi over 6. So that point is pi over 6. Yeah. Now, I put my mark here. That's the one right in the middle of the red one, which is pi over 3, and the black one, which is 2 pi over 3. What do I do to find the middle?
Take the
I add and I divide by 2.
So it's 3 pi over 3.
So that's half of 3 pi over 3. What is 3 pi over 3?
2.
Right, 3 pi over 3 is just pi because the 3's go away. So it's pi over 2. So that's pi over 2. Again, I haven't even graphed, but believe it or not, the hard part is just over. Now, I go back because it's been a while since I even looked at the initial problem. What am I graphing? I'm graphing a cosine. How much is the amplitude of this cosine? 1. So the highest I'm going to go is 1. So at the first point, where do I start? Up top, 1. And then I alternate 0.
Negative 1. Oh, and then you go down.
Okay. So first of all, the period is 2 pi over this number,
Does it always start at 0?
and that's just pi. Please raise your hands if you have questions. Okay, so 0, so that goes to pi. Now, we're graphing cosine. It's all, cosine's always going to be from 0 to 2 pi. The number, the value that I put in there is what's after the cosine, which is 2x.
Wait, cosine's always 0 to 2 pi?
Sine and cosine always go from 0 to 2 pi. So here we're always going to go from 0 to 2 pi. Okay? So now I divide by 2, divide by 2, divide by 2. So I get 0, x, pi. 0, x, pi. All right, on my number line, this one's a little bit simpler. I go from 0, 1, 2, 3, 4 to pi. Now, what's the point exactly in the middle of 0 and pi? Pi over 2. What's the point? If I have half a pi, what's half of that? A quarter of a pi, pi over 4. And if I have half a pi and then pi, what's the middle between half and it's 3/4 of a pi? Correct. The arithmetic there, please combine. We can work on it more and more. Now I'm graphing a cosine. What's the amplitude of the cosine? 2. That means I'm not going to start at 0. I'm going to start at 2. And then go to 0, down to 0, up to.
Oh, so you don't do anything with the 2 by the cosine, you just use the 2 on the outside and then use the 2
Right,
on the cosine to do
right, right.
Got it.
Okay. Now,
Wait, can you go back?
all right, all frequency is the reciprocal of the period. Okay? So it's b over 2 pi. So basically it's just the reciprocal of the period. Frequency, so period is how long it takes for one cycle to complete. Frequency is if I block off a chunk of the x-axis, how many full cycles could fit in there? Okay, that's what frequency is. So for example, for that blue wave, all right, you see how many in this chunk, okay? Look at how many cycles have fit in there. Now, take a look at this green wave, all right? How many cycles fit in that one? Just 1. So the green wave has a much lower frequency than the other wave. That's all frequency is, all right? Now, how does it apply to you? How do you find frequency? First, you find period. So let's find the period and then the frequency. So what's the period of that first one?
1 over 2 pi. Oh wait, no, that's just the 2 pi.
It's 2 pi over 1, which is just 2 pi. The frequency will be 1 over 2 pi. Okay? You just take the period and it's 1 over that. Okay, here. Period is 2 pi over what? 4, which is
1
pi over 2. The frequency is the reciprocal 2 over pi. Okay, you just take the reciprocal. Okay, let's talk about phase shift. Phase shift is when the graph moves horizontally. Okay? Phase shift moves the graph horizontally. All right? So phase shift moves the graph horizontally, either left or right. How do we find phase shift? So to find phase shift, Okay? What we do, you remember the function was sine bx plus c? We take that term bx plus c, we set it equal to 0, and then we solve for x. Okay?
Oh, phase shift. What's the phase shift? You said the b equals 0?
Set the whole bx plus c equal to 0. Okay? The whole term.
What is this a new thing?
Yeah. This is a new thing. We did period. Now we're doing phase shift. Phase shift is when the graph literally just moves right and left. Okay.
So now we're actually using the formula to do that.
Yeah, I mean, we're gonna, right, so we're building, right? And then we're gonna end up using all of those symbols. Okay, now, amplitude. Let's go back to what we were doing yesterday. The amplitude in this case is 2. The period is 2 pi over, what's the number to the right of the x? I'm sorry, to the left of the x? 1. So it's 2 pi over 1, which is just 2 pi. The frequency is the reciprocal, and it's how much? 1 over 2 pi. So we take this, and it's the reciprocal, 1 over 2 pi. Now for the phase shift. We're going to take bx plus c, that's the whole thing in the parentheses, x minus pi, and set it equal to 0. Okay? Now I need to solve for x. If it's x minus pi, what do I do to get rid of the pi? You add pi. Yeah. So x is equal to pi.
That's the phase shift?
That's the phase shift. Right, so what that means is the graph has moved to the right by pi units. Okay. If it's positive, it's right. If it's negative, it's left. Now, how are you going to graph that then? Well, I'll show you. It's the same exact thing. We're graphing a sine. The default sine always goes from 0 to 2 pi, remember? Okay, so before what we were putting in there was what came after the sine or the cosine. Same thing here. What comes after the sine or cosine? X minus pi goes in there.
Wait, I thought after the sine was 1.
Right, but it's sine of x minus pi now, so that term bx plus c, okay, goes in there. Now, I need to solve for x again like I did before, so I add pi to everything. So I have pi, x, 3 pi. Okay? So now it's from pi to 3 pi. Now things are shifting, changing. Huh? You don't start at 0 this time. The first point that you put on there now is pi, and then you go 1, 2, 3, 4 to 3 pi. Okay? So let's compare to what we did before. What we did before, our inequality went from 0 to pi. So here I went from 0 to pi. So the first and last points here are the first and last numbers there. All right? The one from up here, the first and last points on the x-axis are the first and last points on our inequality. And same thing here. Now,
Wait, why don't we start at 0 with sine?
Because you have to add the pi.
so
It's the
are you okay with how we got this? Now, when you have this, that, until now it was always 0 because we never had a phase shift. But now that we have a phase shift, that's not going to be 0 all the time. So whatever that number is, goes there. It's not always going to be 0. It's just whatever that first number is.
So in the past it just happened to be 0.
In the past, it was just coincidence that was always 0. Okay?
So what's the period to that?
Well, okay, so let's see. From pi to 3 pi, how much distance is there? 2 pi.
Oh, okay.
2 pi. Okay?
So 2 pi is the
2 pi. So that's just saying
Right.
how.
Yes. How long it is. Correct.
Why
Okay.
3 pi not like, why exactly?
Well, are you okay with how we got this?
Yeah, but not.
Okay, so look, pi, 3 pi, pi, 3 pi. The reason why we do this is so we get
Okay, but why did you put 3 in that?
in here.
No, because you added.
Right.
pi.
Right.
Oh, got it.
Okay. Yeah.
Did you say that the period has to be the same as the answer on the right?
No, I said the period has to be the same as the length